Hi, now we are going to demystify AI. You've likely come across various terms recently, and it might be a tad bit confusing as to how they are all interconnected. Well, terms like artificial intelligence, machine learning, deep learning, foundation models, or perhaps large language models. So let's clear up this confusion and place these terms in their proper context. But first, what is artificial intelligence? Well, artificial intelligence, in its raw form, pertains to the simulation of human intelligence in machines, enabling them to perform tasks that typically require human thinking. Now it's in various forms and paradigms. It has been around for decades. Perhaps you've heard of the chatbot called Carrie or Elisa, which was developed in the early 1970s, which could mimic human-like conversation to some extent. Now, a subfield within artificial intelligence called machine learning that enables computers to learn from data and make decisions autonomously. It centers on developing algorithms that allows computers to learn and make decisions based on data rather than being explicitly programmed to perform a certain task. These algorithms use statistical techniques to discern patterns in data and make predictions or decisions without human intervention. But like AI, ML is a very broad term. It includes a range of techniques and approaches from traditional statistical methods to complex neural networks. There are some categories which we will look in the next section, such as supervised learning, which involves training on label data. There's also unsupervised learning, where models find patterns in data without predefined labels. There's also reinforcement learning, which involves interaction with an environment and receiving feedback. Now, where does deep learning all fit within? As you can see, this is the relationship between artificial intelligence, machine learning, and deep learning. Machine learning forms a subset of artificial intelligence, whereas deep learning is a further category within machine learning. So, machine learning forms a subset of artificial intelligence, while deep learning is a subset of machine learning. Traditional ML techniques might be a fit for figuring out linear separations or simpler patterns, while deep learning excels at managing vast amount of unstructured data like images or natural language and uncovering intricate patterns or structures within them. Now it is important to note that not all machine learning is deep learning. Traditional machine learning methods still play a pivotal role in many applications. We have techniques like k-means clustering, a popular technique, or random forests, which we'll all look in a while. There's also a very popular term that's been in existence for quite some time named foundational models. Well, the term foundation model was popularized in 2021 by researchers at the Stanford Institute, and it fits primarily within the domain of deep learning. Well, these foundation models are large-scale neural networks trained on vast amount of data, serving as a base or foundation for a multitude of applications. Instead of training a model from scratch for each specific task, one can train, one can take a pre-trained foundation model and fine-tune it for a particular application, saving a lot of time and resources. Foundation models are trained on diverse data sets, capturing a broad range of knowledge and can be adopted to tasks ranging from language translation to content generation to image recognition. So, in the grand scheme of things, foundation models sit within the deep learning category. but signify a shift towards more generalized, adaptable, and scalable AI solutions. Next terminology is the large language model, which in itself is a type of foundation model focused on processing and generating human-like text. Let's break it down. The first L stands for large, indicating the scale of the model. LLMs possess a vast number of parameters, often in the scale of billions or even more. This enormity contributes to LLM's nuanced understanding and capabilities. While the second L stands for language, designed to understand and interact using human languages. Trained on massive data sets, LLMs can grasp grammar, context, idioms, and even cultural references. The final letter M stands for model, at the core of which all computational models, a series of algorithms and parameters working together to process input and produce output. LLMs can handle a broad spectrum of language tasks, such as answering questions, translating, or even creative writing. There are more types of foundation models. Examples of such foundation models are scientific models, which can be used for predicting molecular structures by chemists, and also audio models, which can generate human-like speech. There's also image generation models or vision models, which can be used to generate and interpret images. There are also recently developments in video generation models as well. And with that, I believe we have covered the AI buzzword bingo scorecard. In the next section, we will look at the types of machine learning and some of their applications. See you in the next section.